maybe we will start. So welcome everybody for our last day of this summer school, and we'll be having a lot of quantum mechanics this morning. So we start together with path integrals, and then we'll have quantum Monte Carlo methods with Michele Casula, and we'll have our practical session this afternoon on both methods. So I will talk a little bit about this later, but basically we'll take the same system, the water dimer, and look at the hydrogen bond with both methods, first with path integrals, and then also with on the electronic structure with quantum Monte Carlo methods. Just a quick word before we begin. At the coffee break, or maybe at the lunch break, you can start to take away the posters, since we'll have to take the grid away in the afternoon. Okay, so let's start with path integral method, and here I mean quantum mechanics, but will be the quantum mechanics of nuclei. Later on with Michele Casula in the quantum Monte Carlo method, it's an electronic structure calculation, so it's quantum mechanics on the electron. What we'll be interested in is the quantization of nuclei. When we heard about molecular dynamics in the first day with Mathieu, the nuclei were classical. They were following the Newton's equation of motion in a force field that was given by the electrons, but whatever, the nuclei were classical. They were following Newton's equation of motion. And there are a variety of situations where actually the quantum nature of the atoms themselves is important. Of course, where the most spectacular manifestation of the quantum natures of atoms are superfluidity for helium, Bose condensation at very low temperature, and so on. But this is not what interests us for in material, in condensed matter science. However, there are a few things where, few situations where it is important. The reaction rate when proton transfer is involved, the proton, as we'll discuss at room temperature, is quantum nature is of its dynamic is important, and it it controls some reaction rates when proton transfer is important, the limiting step.